This will be the wrap up on our discussion of air pressure and wind, and after that, Unit 6B will be concentrating on severe weather. One thing that I didn't get to cover so far are high and low pressure regions. Low pressure regions are sometimes called cyclones, and you might have heard the word cyclone sometimes referring to a tornado. Well, tornadoes are indeed centers of intense low pressure. The pressure gets lower and lower until you get to the center of the cyclone, and it's associated with rising air. Rising air reduces the push on the surface, so rising air is associated with low pressure. It often brings clouds and precipitation because remember, rising air cools, condenses, forms clouds, and forms rain. Winds associated with a cyclone in the northern hemisphere rotate counterclockwise, which goes in this sense as I show here. In the southern hemisphere, low pressure systems go clockwise. Hurricanes are one of the biggest, most intense types of low pressure systems. So if you see a picture of a hurricane and you can figure out which way it's turning, you can figure out which hemisphere it's in. Here's a low pressure system, a hurricane. First of all, you have to figure out which way is it turning. Sometimes that's hard to figure out. Is it turning clockwise or counterclockwise? One way I always figure this out is I start with one of the arms, one of the spinning arms that are out on the outside. And I start there and I work my way into the center. For example, like that, or like that, or even like that. That will tell you the direction it's spinning. And all three of these will show you that this is spinning counterclockwise. So this is in the northern hemisphere. Here are two hurricanes that are spinning in different directions, and these are shown with arrows so you don't have to do the little trick I just showed you. The one on the left is in the Gulf of Alaska, so it's spinning counterclockwise, northern hemisphere. The one on the right is from the southern hemisphere, near the coast of Brazil, so it's spinning clockwise. The reason they're spinning in opposite directions is because of the Coriolis effect. Remember, the Coriolis effect deflects things to the right in the northern hemisphere and to the left in the southern hemisphere. Tornadoes, as I mentioned, are also intense low pressure systems. It's hard to tell which way this one is spinning, but it is spinning counterclockwise because this one is from the northern hemisphere. The opposite of a cyclone is an anticyclone. Anticyclones are centers of high pressure, and the pressure increases towards the center where it is highest. This is associated with subsiding air, sinking air. So air that's sinking, pushing down on the surface, think of that as making high pressure on the surface. Usually this brings fair weather, not necessarily warm, but no clouds, clear skies, because rising air is what produces clouds, and this is sinking air. Winds associated with an anticyclone in the northern hemisphere tend to spin clockwise. One way to remember these, again, this is for the northern hemisphere, is to think about screwing a screw straight into a tabletop. And this only works in the northern hemisphere. So over here, we want to screw that screw down. We want to tighten it into the table. We want it to go down. That's high pressure. And if you think about it, you might have learned righty-tighty, but righty, what you're really doing is you're turning that screwdriver clockwise. You're tightening it. If you want to raise that screw, if you want to loosen it, sometimes you hear lefty-loosey, what you're really doing is you're turning it counterclockwise. So tighten that screw, make it go down, high pressure, make it go down, tighten it clockwise. And so we have a sunshine here, we have clouds here. Here's a whole map showing high pressure and low pressure. And the arrows are showing the wind direction. Here are the isobars. Remember, they don't go directly from high to low. Remember, there are other factors involved like the Coriolis effect and friction with the ground surface. But in general, the wind is blowing away from the high and towards the low. Air can't just rise and go nowhere, so rising air such as this shown going counterclockwise from a low, eventually goes towards a high and then sinks again. There's a whole complete convection cell. This is showing the Tower Bridge in London on 2 different days. Very simply, this represents low pressure weather and this represents high pressure weather. Low pressure weather, rain. High pressure weather, clear skies. As a summary for this entire unit on air pressure and wind, I list a couple points here. Air has weight, air pressure, and that's measured by a barometer. Wind is the movement of air from high to low pressure, and it's controlled by 3 factors. First of all is the pressure gradient force. I've just said that wind goes from high pressure to low pressure. So in this figure, it goes from high, 1016 millibars, to low, 992 millibars. But the pressure gradient force has to do with the force, or the strength of the wind, the speed of the wind. And that has to do with how far apart these isobars are. These isobars are shown every 4 millibars. When they're far apart from each other, the winds are weak. The gradient, or the change between them, is far apart. Here, where they're closer together, the wind is changing more quickly. The air pressure changes more quickly, and the speed of the winds is stronger. The second factor is the Coriolis effect. Remember that because the Earth rotates this way, something that's moving in a straight line appears to be diverted to the right in the direction that the object is moving. So this might look like it's diverted to the left in terms of you looking on the screen, but if you were riding on a rocket traveling in this direction, from your perspective, you get diverted to the right. Friction with the Earth's surface also slows winds down. So the combination of all 3 of these, high to low, air pressure moving you in the direction of the red arrow, the Coriolis effect turning you to the right, and friction slowing you down, results in a wind direction as shown in this gray arrow. There are 2 kinds of pressure systems, high pressure and low pressure, which I just went over. There are the global pressure zones that produce global winds, such as these. We have the equatorial low pressure zone, the subtropical high pressure zone, and between them we have the northeast trade winds. This is an important diagram that you're going to need to use on your next exam. And then finally, local winds are produced by local pressure variations, and this includes sea breezes, land breezes, mountain breezes, and valley breezes. Before I finish up, I actually was in contact with the author of your oceanography textbook. It's a free textbook, as you know, but he mentioned that he does appreciate donations. On the first online page, you'll see a little button down here that says donate, and he wanted me to let you know that even $5 or $10 donations from students really helps out. Most textbooks of this quality would cost well over $100, and some even $200 for students to purchase. So you can write it off as a tax deduction. If you can help out, he'd really appreciate it. And so I just wanted to let you know that. So that concludes air pressure and wind. Unit 6B will now concentrate on severe weather, where we put together all the things we've learned about temperature and humidity, air pressure and wind, and think about weather systems, thunderstorms, tornadoes, and hurricanes.